Welcome to one of the two routing area working group sessions here in Singapore. We'll get started in a moment when everyone kind of sits down and people come on in. I'm Chris Bowers, this is Jeff Tansura, and Jing Zhen is down there. She's our secretary, and she'll be one of the note takers, and she's also been doing a great job keeping a lot of the logistics running for the working group. Probably you've seen the note well by this point. Things that you say while participating in the working group have certain consequences, so please pay attention to the note well and read it well if you haven't already. So there's a sort of generic IETF policy about our IPR disclosure. The routing area working group interpretation of that process, so that we dot all of our I's and cross our T's, is to require that document authors and contributors state whether or not they're aware of any IPR relevant to the document in question. Also others should generally do it as well if you're participating in the working group in any fashion. And we do it at two stages in the working group document process, both when adopting individual drafts and then before working group last call. So we have Ying Zhen doing the note taking. Do we have a Jabber scribe? Okay, you're on Jabber, so that's good. The blue sheets are already circulating. That's good. I'm going to switch over to the agenda. Is this one? Okay. It's traditional for people to have an opportunity to give feedback on the agenda. This is the agenda that we have published for today. We also have another session on Friday that we can, if there are any issues with this agenda, we can generally catch up on the second session. So moving back, go on to the, whoops. Yes. I'm going to go through a review of the working group document status. We had no RFCs published since IETF 105. Documents that have already been submitted to the IESG for publication have changed state a little bit, but they're sort of winding their way through the process. This document has been on, in this state for quite a long time, so I think Jeff is going to comment on this.
So we've decided to change the Shepherd and engine. Thank you. Agreed to do Shepherd's review, and we'll progress this draft.
We recently adopted the QoS model draft as a working group document. There are several, so this is a list of all the existing working group documents. Several of them, the ones listed at the top, the draft that's published has expired. It would be a good idea we have an update from the first, I think the editor of the first draft, the TILFA draft. Would you like to address this?
Yeah, so Stefan Likowski speaking for TILFA draft. I'm currently working on it. I just need more time to work on the data plane procedures, which requires a lot of text review, but some changes are already done, but these data plane parties will take more time. Sorry for that.
Okay, well, thank you. Thank you. The ATN BGP draft is expired. It would be good to just keep it current, even if there aren't substantive changes, just to keep it top of mind. The data tracker now has a way to show expired drafts as well. So I'm showing these, but it would be good to not require that. So the VRP BFD point-to-point draft, I sent out an email to the authors of that and requesting that they, at a minimum, do just a bare update with some sort of administrative changes on that. You know, it would be good to get an understanding with respect to that draft about if anyone's implementing it. And that kind of, you know, when we look at it and see it's expired, what does that mean exactly? Does it mean that it's stable and no one, you know, or does it mean that no one's implementing it? So it would be good to, in terms of figuring out how we proceed, to get that feedback. But first off, please just update the draft so that the administrative issue can be dealt with. The desk source routing draft is also showing expired. I guess David had asked about adopting that. We should probably start a discussion about adopting, or rather not adopting, but doing working Google Last Call for that draft. It's been in its current state for probably a year and a half or so. So the other drafts here, I think the first two we're going to hear about. And I don't think we have presentations on the other ones. Okay. Okay.
So RPM model require minor changes, and we plan to last call it after this IETF. Policy model, I assume the same. Engine, who is the main author, I think we discussed it. We plan to last call it between this and next IETF.
Yunjin speaking for both the RIB extension model and the for both the RIB extension model and policy model, both are stable for one IETF, more than one IETF. I think we are gonna last call after this IETF.
Let's see, is that, I think that's the end of that. Okay. So I think first up is Linda. Oh. Well, so maybe they're going to adjust it once someone's there. It might.
Good afternoon. Can you hear me? Okay, good. Okay, give an update, and this is my third time doing this update. I hope I won't fall into those one of those expired drafts and give up. But anyway, thank you for the comment. I made changes to this presentation. So, so I'll give the update since IETF 105 on the network to cloud problem statement and gap analysis. So the purpose of the document, I got quite a few comments when I reach out to people. Hey, can you give some comments on this draft? I got some comments, people saying, well, you describe lots of problems, and what are these for? It's not really for educational purpose, right? So I want to make clear to people that there are lots of problems associated with cloud interconnection. And some of the problems are not something I think within IETF can do. So this draft in particular is really to identify some of the problems on the network problems for network cloud interconnection, and to see that if there's anything our IETF can do, or maybe IETF already have. So that was the purpose of this documentation. Make it clear. So the since IETF 105, it was pointed to us that we need to include the scenario of intercloud connection. So what happened? Okay.
Ultimately, this is a benefit, I think, that it's bigger now. So
okay.
There's a temporary setback, but
okay. So all the cloud, public cloud data center today is primarily between client to the cloud. Okay, you can have different ways to access the cloud. And however, if you have some workload in AWS, and if you want to connect to Azure, you pretty much have to hairpin back to your customer gateway to interconnect them together. So the scope of this document we call network to cloud is really to address the network perspective to interconnect them. How do we manage like VPC from one cloud to VNet in another cloud, and maybe like Oracle may have a different way to identify their the private network and how they use different net. Oh. Okay, so here just a brief summary of what's added. We added interconnect hybrid cloud, the problems associated with them. We also add a section to talk about some characteristics of application hosted in the cloud, the connecting to them. One of the thing is like we know the network augmentation. It's not just one network connecting to the cloud, and lots of times multiple ways. And you may have network stitched together, or you may have network multiplex together. Another thing is application-based policy. Those policies can change based on where the application is. So it's basically away from the traditional, we have a firewall, we define our access list, our security policies on the specific appliances. And when you have application in the cloud, the policies actually move with the application. You have to have a way to specify those policies are specifically for those applications. When application move from this location to another location, the policy has to follow them. Basically, that's another difference from the traditional networking. And third part is application-based forwarding instead of destination-based forwarding. In the network for so many decades has been always using destination as the way to forward. But many of the application today is really using application ID to forward. And different application may need different topologies. So that's some of the key characteristics of connecting to cloud, which is different from traditional networking. I add a slide. This is actually primarily from Aliyah's suggestion, the key requirement. For accessing the cloud, one of the key things is authentication, authorization, right? So you could have a particular application in the cloud, and then depending on who's accessing it, you have different policy, right? Or you can have policies on this cloud application saying, hey, if the traffic request from the on-premise headquarter data center coming in the request, you can grant the communication or processing. But if the request traffic coming from Azure data center, then you don't have any communication. You drop it, or you may report. Or maybe the policy is changing, like, for example, from a certain time to certain time, you have different authentication methods. And then when you have two cloud data center, when one application needs to connect to another application, how do you do the authentication? How do you do the authorization? So that's a big thing about inter-cloud communication. Second part is in the cloud access, one enterprise can create multiple VPCs, right? Like, for example, a big corporation, you may have a VPC for your testing environment. You may have a VPC for your production environment. And you could have the same application running in different VPCs. But when the traffic actually coming from this data center or cloud data center to your campus network, lots of time you cannot tell which VPC it's coming from. You have an address, it doesn't attach with the VPC number. And similarly, you have Azure's VNet. Similar thing, the VNet and VPC, how do I make sure that they actually belong to the same client or same domain? So you may have a subnet, like we call subnet, belong to one particular group. But when you assign something, put something into the AWS, they have a VPC. You put something else into the Azure, you have VNet. How do we combine them as one identity to show they can actually communicate with each other? So that's something has to be addressed. And there's another thing is about API, right? But this API actually, I'm not sure if IETF can do anything about it. It's basically different cloud data center have different APIs to create their workload, to do assign net, to do all kinds of functions. And many of the enterprises today, they all need consistent APIs so they can move from one place to another place. Stewart, you have questions?
So maybe I don't understand what you're proposing, Linda, but you keep talking about various proprietary cloud designs, which are, of course, entirely within the scope of the provider to define and modify the APIs as they want. We don't normally sort of do interfaces between proprietary systems. We only really ever design standard solutions. So you could have a sort of a shim layer that we define that they have to map to, but I don't think we should be talking about mapping between proprietary systems.
I'm not proposing that. I'm just saying this some of the problems appearing, and this may be out of the scope of IETF. I just put it there. This is one of the problems facing by many enterprises when they access multiple clouds. That's all I'm doing here. I don't think that's something we need to address. That's my personal view.
Okay, that wasn't it wasn't very clear.
Okay, okay. And another problem requirement is the net. How do they do the net? Different cloud provider has different methods. And how does the network handling different net methods and DNS? And also that is any way to discover how many cloud data centers this particular application is connected to, right? Those are some of the key requirements for the multi-cloud. For the key problems, that's the focus of this particular document, is really to address some of the problems enterprise facing to connect to the multiple cloud. So, with different cloud is basically like you have different access methods, right? So I'm repeating myself. So that today you have to hairpin back to the campus network before you can reach to another cloud, make it very difficult. Second thing is as an application itself residing inside the cloud, it's because the cloud allowed different ways of access, right? You can access through public internet, you can access from IPsec, you can access from the direct gateway, direct connect. And as an application themselves residing inside the cloud, they cannot tell which entrance, which gateway it comes in. That's how today's design. And with that, it's difficult to make a consistent performance measurement, or maybe applying different policy depending on which entrance you come in. If you come in from IPsec, maybe I should have one set of security functions. If you come from direct connect, maybe I should have another set of security functions. If you come from the internet, maybe I should add more of DDoS attack, right? There could be many DDoS attack coming in. And another thing is the IPsec itself, right? So IPsec itself, IPsec is point-to-point, right? So point-to-point works well when you just have 2 points. When you do the configuration, you configure who are you, who is your remote end. And, but the problem is when you have multiple sites, when you have 10, 20 sites, and this configuration becomes very difficult. And especially if we have two different cloud data centers, using IPsec becomes not easily to manageable. So even though the Azure today allow you to, I think AWS had a recent announcement to support IKE v2, so allow them to be automatically exchanged the keys to allow automatic creation of the IPsec. So another problem is the MPLS. Like many enterprises today use MPLS, and but MPLS network is fixed, and it is not easily to be extended into the cloud. So for whatever access you have today to access your workload in the cloud, you have to do some kind of stitching. So that brings up another issue of how do you do the end-to-end performance measurement, and what kind of measurement you need to attach, what kind of metadata you need to attach. For example, if you're an enterprise here residing inside your on-prem data center, when you have traffic coming in from different cloud, what kind of metadata you can carry within your packet so that when you arrive into your on-prem data center, you can tell immediately which location it comes from, which VPC it comes from, which VNet it comes from. With those information coming attached in the metadata, you will be able to do appropriate actions. I'm not advocating a particular solution or anything, but there's just some examples of IETF work, like metadata in SFC can be applied to this kind of situation. Okay. For the gap analysis, I just added this. In the past, we've been talking about using tunnel in-cap to carry the IPsec information, to carry the net information. That is in IDR, there already a document proposal on how to do that. And in the BESS, we have a informational draft showing how do we use BGP to be able to distribute the IPsec information to establish those the tunnels. But one thing hasn't been addressed is this application-based forwarding. In this example, it's showing that I have those nodes, like for example, a payment system. They can only talk to the payment gateway in a particular location in their headquarters. And then other applications can communicate point to point. It's a multi-point connection. And if those applications have different address, then this can be achieved very easily with the routing protocols we have developed. It could happen that the application ID, like this red application payment system, and some other application from the same user may have the same address. This can create some problems on how do we distribute that information, because the application red has to only follow the point-to-point topology, the tree topology to the payment gateway. They don't allow the red application to talk among each other. The purple one is another type of application which is allowed to be multi-point. So one address has to be put on into two different topologies. I think that's something I'm not sure if IETF has anything or not. I'm putting here on the table. I know we have lots of experts in this room. Solicit any input. If you have any good suggestions, hey, this is something IETF already done, that'd be great. And would love to document that into the into this document. Another thing is the IPsec today is among the client traffic. You create client traffic and you create IPsec tunnel among those clients. That is well between if you just have 2 nodes, but if you have multiple nodes, and it can be difficult. So that it will be good to be able to create some kind of port-based IPsec tunnel. So treating the IPsec tunnel as a transport pipe, so that different traffic can be multiplexed together or be forwarded. All those nodes along the way, like CPU1 or CPU2, can be the one as a forwarder, almost like creating a VRF over this untrusted network. So that's something is not yet there yet. So next step. So we want more review. I promise, Chair, that I know that people are very tight on time. You don't have much time to everybody has lots of work. I promise I'll write a very simple document just along the line I present today, maybe 1 page, 2 page, take you maybe 5 minutes to review it, to see if those problems have been properly identified. Yes.
Wim Hendricks, Nokia. I don't know where I have to start, but in my view, this document is all over the place, in my view, right? Because you started with saying a problem statement for net to cloud, but you're mixing SD1 problem statement with net to cloud problem statement. And I think you have to contain to a specific space you want to address. And either it's cloud or it's SD1. But right now you're mixing it all over the place. And as a result, I think you're putting too many things into it. And as a result, it becomes unreadable and people probably get lost with it. That's my personal view. So my question is, should you focus on cloud interconnection? And I think then that's one option, or you should focus on SD1 problem statements interworking with cloud or something. But right now, from reading the document personally, I don't see where you want to go here.
That's a very good suggestions. We're going to focus on the net to cloud for the cloud interconnection. So we'll take out all the SD1 mentioning. We're focusing on primarily we use network to connect to different clouds or multiple clouds. What are the problems we have today? What are the possible solutions there could be? IETF already have.
Because I think then, if that's the state, then I would say focus on 2 requirements, because you have internet-facing use cases, which are like SaaS, internet-focused, and there is private VPN use cases.
Okay.
I think my suggestion would be to focus on these 2 areas.
Okay.
And contain it like that, because otherwise you're mixing things all over the place, and as a result, it becomes much more clear what is there and what needs to be done for those type of things.
Thank you very much. So the note taker, please write that note. That's very helpful suggestions, definitely. Any other comments? Okay.
Comment. So if you feel that SD1 work is valuable but lower priority, you could spin out another draft and just postpone the work till the first one is resolved.
Oh, okay.
I mean, you've put quite some effort into it. It would be too bad just to delete it.
Okay, so you're saying like separate the work, like
it's up to you. It's your work.
Okay. So what I would do is create a very short draft just to describe the problems with network to cloud, and then associate problems. I want people to give input just for that specific domain, not worrying about SD1 or MPLS, just talking about that. And if I find some of the material in the document are valuable, maybe I'll create another document. Okay, thank you. Thank you very much. Thank you for your suggestion. That's very helpful.
Next up is Shuping.
Hello, everyone. I'm Shuping from Huawei. And on behalf... Okay. Hello. Hi, I'm Shuping from Huawei. And on behalf of all the co-authors, I'm going to present you about the APN6. That is application-aware IPv6 networking. And currently, we have 2 drafts. One is a problem statement and use cases. The other is about the initial framework proposal, and we would like to have your reviews and comments. Thank you. And first, about the motivations. That is why we want to propose the APN 6. As we know that the network operators have been facing the challenges of providing better services to their customers, especially nowadays, as the 5G and the industry verticals evolves, and more new applications with diverse service requirements are accessing the network. And so that will be desirable for the network operators to be able to provide the differentiated fine granularity traffic operations and to guarantee their SLA. And is it for me? Okay, sorry, I thought it was for me. And also, moreover, and as the technologies evolve, and currently there are online gaming, live video streaming, and also the video conferencing. Those applications are widely deployed and used by the end users, by the companies, enterprises. And those applications have even more demanding requirements, and they are the actual revenue-producing applications. So the network operators would be good to provide the application level SLA guarantee, fine granularity SLA guarantee. But however, the current network doesn't have such capability of application awareness, and the network operator is not aware of what applications are actually traversing their network infrastructure. And to guarantee the SLA, currently the operators can only use the light load, and sometimes even 10% network utilization. So the network operators just keep investing in their network structure, but they haven't got the corresponding revenue increases. And actually, they are losing the opportunities to have the new revenue. So fundamentally for us, the motivation is to bring the application information into the network and to make the network aware of the applications and as well as their requirements. So, and here, and we would like to take advantage of the big trend for now. That is the IPv6 and SRv6 are being widely deployed. And the programmability provided by IPv6, that SRv6, that is the programmable space in their encapsulations can be utilized to convey some information from the application side into the network. But of course, and other protocols with certain extensions could also serve the same purpose, but we cannot ignore the IPv6 and SRv6 are the big trend for now and for the future. So basically, APN6 wants to achieve the application awareness and to have the application visibility in the network, to empower the network operators to provide those fine granularity traffic operations and to have corresponding revenue increases, and to allow the requirements of the applications to be specified to the network. And regarding the application informations, that could include the application identification and the SLA requirements or service requirements. And with those application information carried in the package, and the network could provide the corresponding network services. And we have identified 3 key elements for APN6. The first one is the application information conveying, and that could be the application itself or the edge devices to add those application information and with the augmentation of the existing encapsulations. And just to be noted, and that is not enforcement. That is optional. It's up to the applications to decide whether to add it or not. If they don't add those information, and their packets will be treated with the traditional way, of course, they couldn't get the benefit of the provided by APN 6. And the second element is the matching between the application information and the network. So that is like the network provide its capability towards the application, and according to those application information, and the network could provide corresponding services like the network slicing, deterministic latency guarantee, or SFC, etc. And the third one is the network measurement, and that is to achieve the better or accurate matching for the second element. So because the network capability is changing over time, and in order to have the accurate matching, and the network needs to keep monitoring its performance, and then provide this the better matching here. And here is the framework, and as I said before, the application and the edge devices could add those application information, and then in the head end of the network, and according to those application information, and the network could, for example, to steer those application flows into corresponding SRv6 tunnel with certain SRA guarantees. And along the path, and in the middle point, and according to those application information, and we could also do some manipulations to those packets to guarantee their SRA. And here another highlight is this flow-driven method could enable this fast service provisioning. And we have done a lot of communications with our customers and with verticals and the industry here. So we have identified some use cases that could directly benefit from the APN 6. And here we have categorized into the following 5. The first one is the fundamental one. That is the application-aware SLA guarantee. That is to enable the network operators to provide this differentiated service treatment and the fine granularity traffic operations capability. And then the second is the application-aware network slicing. This is for some applications that they have the specific requirements, and in order to guarantee their to satisfy their requirements, and some levels of isolation probably in terms of the service isolation or resources isolation to guarantee their requirements. So for those applications, they could be steered into certain network slice and to guarantee their requirements there. And for the multiple different applications, and they have various requirements, they could be steered into different network slices, and those applications could be served at the same time and in parallel. And again, the third one is application-aware deterministic networking. For some applications, and they will require the deterministic bounded latency guarantee. And for such application flow, they could be identified first and steer into the certain deterministic path. And then is application-aware service function chaining. So here is again, and the application flow is identified, but without the help of DPI. So it could be identified and then steered into certain SFC. And in the sequence steering, you can just use the application information carried in the packets and to manipulate the packets. And then finally for the application-aware network measurement, and that could empower us to monitor the application level, the performance and to locate the failure, the potential failure that could arise. And here, just briefly to update with you and what happened in the last time. And we host an APN6 side meeting in 105, and this is the meeting room. And we have about 50 attendees. And we have very good discussions there. And we roughly achieved the rough consensus about the value of the work. That's why we decided to continue. And this time we have 2 new drafts, and together with all the collaborators. And so we want to push forward. And for the next step, and we would like to have a mailing list for us to continue our discussion. And now we can only have the separate discussions. And also we are also planning to, we are thinking to have a BOF for the next meeting. And but here, and this time we are presenting in the Rtgwg, and we are really sincerely looking for suggestions, especially to the chairs here, and how are we going to move forward on this work. So that's all. Thank you. Any questions?
Wim Hendricks, Nokia. A quick question. Why do you contain it to IPv6?
Why we config?
Why do you contain it to IPv6? Because you can also do this with v4, in my view.
Yes, I agree. As I mentioned before, it doesn't have to be at IPv6. Okay, and so it could be all other protocols, but for example, v4 or MPRS, but we have to admit they have limited the programmable space. We have to do it with extensions to support.
But with segment routing, you have, whether it's with MPLS or with v6, it's you have as many parts as you have available, so it shouldn't be contained, in my view, to only v6.
For the
and you can use SFC as a tagging. There is already application definition inside, so it can tag information. So you could use that work which is available to achieve this objective, in my view. Yes,
and we acknowledge those, and we have done analysis on all the fields and to figure out the possibilities. But here we would like to carry not only the very simple ID and the SLA requirements. Actually, we could take the metadata related with the application, whatever you can imagine.
Which you can do with SFC. SFC has that capability. You can put metadata in the packet.
Okay, okay. This is Robin from Huawei. The first one, I think that's the first one I want to say that's why we discuss in Rtgwg. I think the data plane is true. Now it's open. Because at the beginning, we think the IPv6 has the advantage because this the application support IPv6, and now this network side, also the SRv6 can be combined through IPv6 seamlessly. That's the point. But I think it truly can be open to the MPRS or VXLAN based if possible. The second one I want to say that the SFC, true. It has some the application information, but from our point of view, I think it's not enough. On the other hand, for the metadata, I think it's because the metadata is not standardized well. That's the point.
Oh, my only comment was it's perceived as it's contained to IPv6, and I think if we go down this path, which is to be decided, I think we should make it open, right? Yeah. Although I believe IPv6 is the future, that doesn't mean that we have to contain it to only that.
Yes.
Okay. Thanks. Thanks.
Eric Klein. A couple of thoughts. One, for a technical body, I don't find revenue-based arguments very interesting. I would suggest maybe remove those from the documents. Also, broadly speaking, this work has some serious network neutrality implications. Application-aware edge devices are one thing, but in the I guess in the framework document, you talk about an application end nodes sending this metadata. And that has some serious privacy applications. And market dynamics being what they are, you know, RFC 2119 may versus must, it's a very short step from may to must for some networks. And you could end up in a situation where you're forcing devices on, say, a large network in a country to basically self-DPI their traffic. And I think none of these documents discuss any of these issues that I could see. And I think that's a huge problem.
Yes, we acknowledge this security and the privacy issue, and that is also noted in the draft, and actually both drafts. And we know we are aware of those mechanisms are needed. And for example, so some automation access control and also the authentication of those IDs, the application informations are needed. And here, that would be one topic for us to explore there.
Right. The potential for abuse is not discussed really, right? And that's the real concern here, I think.
Okay.
So I would like to add to that, and looking at the six-man SRH discussion, they're very much focused on single domain. You're proposing internet-wide.
We could start with the single domain first. And as we discussed with the operators, now they own their the network and as well as the application, the cloud. So they could do it within one domain. And
so my point, privacy should be central point of your work. If you cannot provide proper privacy, technology used is not really useful.
Yes, the privacy, to my understanding, is related with information exposed by the applications, but that information could be encrypted in some way. So, and also those information, once the application registered itself, it needs to be authenticated. So,
sure. Yeah. I would like to encourage you to point this issue centrally in your work and work on it so you have clear explanation how you're going to do it.
Okay, thank you. Yes.
Hello, I'm Ajman from Thai Telecom. I think this approach is useful for the application-aware visibility because we often say we want to make sure the applications cohesive assurance for end-to-end. But for the application-aware SLA insurance, I think it may be may exist some difficulty for the deployment in the network because the application, there are many applications. So if you encode the application ID in the network layer, I think the router cannot keep so many state for the selection of the different paths. I do not know how you consider this extensibility.
Yes, and that is so first of all, and that is depends on the device capability, and from the scalability provided by the large number of applications. And first of all, it's not all the applications will pursue in this way. That is only for the the demanding applications. They have specific needs to be satisfied in the network. They could utilize in this way. And
I think for traditional IP network, for the SLA assurance, we often classify the traffic into the several categories. So I think for the numbered category, the network can easily deploy the different paths. But for the numerous applications requirement, I think it is not possible to deploy these different
we'll cut the line
end-to-end paths.
Yeah, sure. I think that is about the application ID, the how to design this ID. Currently, we have the segment, different parts, and that could somehow to categorize, as you said, into the traffic into groups. So
just a time check on this discussion. We had only allocated 10 minutes, so we'll hear the questions or responses from the two people that are currently up, but we should wind it up in the next 2 or 3 minutes, okay?
Can I talk? Oh.
First.
Oh. Hi, Doug Montgomery. I apologize. I haven't read the drafts, but I had two simple questions. You said that you clearly say in the drafts why you can't achieve what you want to achieve with existing virtual path and QoS technologies? You do that gap analysis of why you can't achieve this with the existing mechanisms?
Sorry,
yes. In the document, we specify the problem statement. The Robin Huawei. In the document, we have the analysis of the network. Yeah, the first draft problem statement and requirement.
And my second question is of equal ignorance about this. Are your IDs something that have global significance and global uniqueness?
That just depends, and for the certain domain, and we are thinking it first of all it will be valid within this its operational domains. It doesn't have to be global for the first stage, and for sure I think the multi-domain we also acknowledged in the draft, and that needs to be considered because the ID needs to be delivered across domain.
Linda Dumber from FutureWay. Disclosure, I haven't read this draft before today's meeting, but just glancing through the draft, I find it's very useful. Even though people bring up security concerns, if we can have a mechanism to hide the user information, do some kind of mapping that bring the application information into the network, that will bring tremendous value. This bring up to the discussion which happened in other SDOs, in the MAF, in the cloud architecture discussion. Customers wanting application-based forwarding is not based on IP address, but based on application ID. Different application require different topology. I think this will be very, very useful. That's just my comment.
Thank you.
Next up is Waimo Chen.
Hi everyone, I'm Waimo Chen from FutureWay.
Pull the microphone up a little bit.
Okay. Hello everyone, I'm Waimo Chen from FutureWay. Today I'm going to talk about SRv6 path egress protection. So first we have an overview. Right now we have SR path fast protection for transit node. Here we propose SR fast protection for egress node. So for example, we have SR path from P1 ingress and then to P3 as an egress. So this path, SR path, carries the VPN traffic. So in order to provide protection for P3, which is the egress of this S path, this SR path. So we will have a backup egress node. Here is PE4. So in order to provide protection, we configure on PE4, which is a backup egress. So the configuration is that we just configure a mirror ID, which is to protect PE3. And with this kind of configuration, and then there's some actions going on. So one action is that the information about this protection will be distributed in the network. And then at the same time, on the PE4, which is an egress node, a backup egress node. So PE4 will generate a mapping. So this mapping will map the traffic for for VPN traffic. From when the traffic received from backup path, those traffic will be through that mapping to the destination, which is CE2. So after configuration, so on the previous hop of egress node, for example, here is P1, and that P1 will create forward entries for protect the P3. Here, for example, on P1, when on P1, which is previous hop of egress node P3, when P3 fails, P1 will detect the failure. So P1 will send the traffic, which is targeted to PE3 to the backup egress node, which is PE4, through backup path. So before sending those traffic to the backup path, to the backup egress node, so P1 will just modify the package a little bit, just add that mirror ID to the package. So when this modified package is delivered to PE4, which is backup egress node, so PE4 will use that mapping to map this, because we have a mirror ID in that package, and then we have a mapping entry in the PE4. So PE4 will map this package using that mapping entry to the local VPN ID, and then that local VPN ID will also, because well, you in the same VPN, so that package will finally deliver to the CE2. So we provided the protections for failure of egress node PE3 in fast way. So regarding to the updates to the previous version, so we just added two sections. One is the security considerations, and last one is IANA considerations, and then we updated the reference, and the third one is some editorial changes. So any other comments and suggestions?
Just a question. Have you considered whether this will work with SRM6?
This is SRV6. You mean M6, or you mean the original, the
Security compiler, yeah.
Yeah, I think that's a good topic. And then if that one moves forward, and then we can upgrade this one to also provide solutions to that the compressed or enhanced that one. Yeah.
Okay. Thank you.
Good.
Okay, Wei Chancheng from China Mobile. At first, I think this solution is really useful. I think because during 4G, China Mobile deployed a lot of dual homing protection function. So I think this function can be used in the future. And I have a question about the mirror node. So here you just list the one mirror node. Is that possible configure more than one mirror node?
Yeah, right now, here we have only one backup path, backup egress node. So you mean we want so here for the mirror to one node or two nodes, I think in the in this document, so we can provide protections to multiple locators. So if you think that that is a mirror to multiple, and then that's the mirror to multiple. I don't know whether you mean that.
My meaning is that currently you have a PE3 as a working node, right?
Yes.
And a PE4 maybe is a protection node.
Yeah, backup, yes.
Yeah, the backup one. Is that possible? We have a such as a PE5.
Oh, I got you. You mean so we need a
yeah.
So this is just one redundancy. We want maybe M redundancy. Yeah,
yeah,
that's
yeah, multiple redundancy.
Yeah,
so
yeah, no, yeah, that's I think that's a good topic. I think we so in this draft we don't provide solution for that one. I think maybe in another draft, we can consider that one. We can provide a N-way protection, something like that.
Okay, thank you.
Ajun from Telecom. One question first. Can mapping activity be finished automatically on the backup router, such as PE4 can do the mapping seed allocation automatically?
You mean the
currently you said the mapping seed is configured on the backup.
Oh yeah. I got it. So right now, so one way is through configuration. So another way maybe is through. So this right now, because we have a central controller, if we have in the controller environment, so those kind of configuration can be automated through the controllers. So the controller can select which one protect which one, and then which ID provide which locator, and then those can automated. Do you mean that way?
Yeah. I think this mechanism should be implemented automatically in the network. So because we cannot know which node or which link will be broken down in the network. So I think if such a mechanism can deployment automatically with the network, it will ease the management of the VPN protection.
Yeah, you're right. I think this draft is just propose a basic solution, and then based on this basic solution, we can have a very comprehensive automatic and solutions. Because with if some nodes or server or controller have a high-level view, and then he know which node can provide some kind of protection for which node, and then whether we have enough resource and link to support this protection.
Okay, thank you.
Shraddha David Juniper. So you could use anycast locators to achieve the same thing, right? So I was just wondering why that doesn't work here. Anycast locators? Anycast locators?
A locator is here. This locator just provides some kind of association for the node, for the user node. So for example, here we configure PE4 to provide a locator, some number, and then this.
Yeah, just the same locator on P3, P4, and same customer would get same SIDs. It's same VPN SID.
Same SIDs. I don't know what do you mean exactly. Same SIDs or same locator or different locator. If you can give detail.
Locator is anycast, so it is same locator on P3, P4. VPN SID can also be same because it's just another 128-bit address.
Yeah, in that sense, it's okay. Yeah, as long as we can associate with this locator associated with.
Yeah, so you think it works?
Yes, yeah, I think so. So if it is a locator associated with that node, and then that node fail, and then we will forward get around the traffic, right?
So would it be correct to understand that what you're proposing is backup solution? So unless primary is down, secondary will not take over, while with anycast, you just use closest node. Would it be right?
Yeah, maybe for her question, we can go to details. I don't know exactly what is semantics in this context.
So if you could address on mailing list. So again, I assume that what you're talking about is backup, while what Shraddha was proposing is anycast.
Yeah.
There's some difference in semantics.
Yeah. Okay.
Louis Chen, Juniper. One question is that the PLR on P1, if we want to protect the VPN, do we need to look into the deep more packets? I mean, deep into the labels, so that to locate whether it's a protected or not protected. I mean, P1, how many labels you need to? I mean, how many V6 labels they need to inspect?
Oh, you mean the here is a. So regarding to the VPN, so for example, here we use a VPN SID. So because for VPN, we also need more information. So those detailed information, I think, is in the draft. So here we don't in this picture we don't give details about those information. I think basically for VPN, for example, a VPN, so this VPN for one prefix, those VPN can be associated by those kind of same VPN, and then same VPN, for example, on the PE3, we have VPN ID for the on backup equals, we have another VPN SID. So because we know this is on the same VPN, and then those we can associate those one. So that's the mapping come from. So for the VPN ID on PE3, that's different. On PE4, the VPN ID is another one. So when PE3 fails, P1 will detect the failure, and then P1 will modify the package, just add a mirror ID to the package, and then the VPN ID on the PE3 not change. So when this package is delivered to the PE4, and then because we have a mirror, we use mirror ID, mirror that VPN ID on the PE3 to the local VPN ID, which is on the PE4, and then because those, even though we have different VPN IDs, but those two different ones are for the same VPN, so we can deliver to the same destination, which is.
So you're synchronizing the VPN.
You're eating into your second presentation. Would you be okay to present it on Friday? Because we are running out of time.
Yeah, I think that one we can go short, because Friday I have another presentation is the conflict with the PCE. So I already.
Okay, then we will cut.
You maybe go to list for this one, because this one they give very detailed, and then I can talk to them with on the list, and then this one I can go quick.
Please be quick.
Yeah, 5 minutes. Okay.
So, do you want to ask me a question or not do something else? Or?
Please to the
list. On the list, because we're short of time right now.
Okay. All right.
Also, can we ask for adoption for this one, or?
Well, before you ask for adoption, I think there's a few technical problems you need to solve, not the least of which was whether the Anycast solution is a better solution or not, and also exactly whether you're actually conforming to various architectures in the design. So I think we're a little way from calling for adoption.
So I really ask you to use list to discuss all the options, provide all the comments, and we'll see after that. But you understand, you need to resolve all the comments before we can. You need to resolve all the comments.
Okay.
Thank you.
Okay.
Please go to the next presentation.
So this one is about the architecture for use BGP as a central controller. So basically, BGP is already use a controller in some way, somehow. For example, we advise the SR policy, and then direct the traffic, and then we have some advantages for use BGP as controllers. We list the number of advantages here. So basically, this draft, we propose 3 reference architectures for BGP as a central controller. So one is a single controller, and then another one is a controller cluster, so which is the middle one. So we have here is we have 2 controllers, which forms a cluster. In general, is N controllers, which forms one cluster. And then the third reference architecture is a hierarchical architecture. So this is this document just provides some kind of informational architecture reference. So we present a couple times. I wonder, do you have any questions for this one? So can we ask for adoption for this one?
Yeah. John?
Yeah, I'm done. Okay, thank you.
John, who is probably asking us the chair.
John Scudder. I am not up here with any chair hats on. I guess my question is, and I think this has been asked, if I remember right, in previous meetings, and I don't really know if it's been answered, or if it wasn't, I forgot, I'm sorry. Why do we need to work on this in the IETF? And I'll give my own answer, which is, so far I don't think we do. It's something that people already have been doing for some years now. seemed like we could do it just fine without any RFC, and so I would discourage the working group to take on this extra work. But if you have a convincing reason for me why we do need an RFC, please go ahead.
Yeah, I think this is you see, I know we have already used this kind of idea, whatever. So I think maybe we have some document. So just the document, some kind of reference architectures, just as a reference, as an informational, maybe I think it's helpful.
Stefan Nikowski, I don't like that you talk about BGP as a controller. BGP is just a protocol, so it can be a south interface of a controller, but it's not a controller at all. So you can define a controller architecture, but it has nothing to deal with BGP. BGP is just an interface that the controller could use to program a path, but we already have the extensions defined to do so. So I don't really see, the need.
Yeah, great idea. So your idea is we can generalize. So this BGP is just one protocol.
There are already some framework of controller architecture in IETF.
We are going to cut here. Dean?
You're up next, Dan. We're going to go to the next presentation since we've already cut it down to 20 minutes. Thank you.
Make a joke that we had GMPLS. Why don't we do GBGP?
Hi, my name is Dejan Bogdanovic, and I want to do some thought experiments, and here are some of the food for thoughts. In a way, it's also a continuation from the last presentation, and to figure out how we can evolve the network automation and the network programmability. We have to ask ourselves a little bit more, and how do we want to continue getting to the goals in order to enable better operational productivity for the network operators? Is there a value of splitting things up into multiple layers, splitting the decision-making? Where should we make some decisions? Should we focus on continuing everything on the network hardware? Should we try to think more of that and see what should be running there, what should not be running there? And what benefits can we get out of that? What are the useful features for us that we are looking to do? What is important to the operators? Something like, hey, can I inject retrieve information that I can change some routing policies? Do we want to be able to do that fast, presumably in the real time? Or do we want to inject it and say, oh, it will happen at one moment in time, which is pretty indeterministic? And do we want to offer them different traffic engineering optimization points that that can be done? How can we, again, this comes down to real-time actions. If there's something happening, that we can react in that we can enable an application that detects that to put a fast reaction without waiting for the human network operator to execute on the action. So there are any of those features useful? And the reason why I'm asking that is that traditional vendors in the past, I'm not sure if this still is the presence, but in the past they were giving you some lackluster support for that. I mentioned here too that I was part of it. I know about another one, but it was proprietary interfaces. It wasn't the friendliest, environment to develop to the third parties. You have to adopt many vendor development policies in order to be able to do that. And they were never too happy to do it or to expand it. You were asking, I want this, I want that. Well, you cannot have this and you cannot have that, but maybe you can get this and that. But in general, many operators found it useful because it enabled them to react faster and automate some of the reactions, onto their network. And many years ago, we looked what is constituting a network element, and we said, okay, we have a network OS, we have a network hardware, we have essentially a set of daemons that are running inside that, everything nicely packaged up. And what we did at the IETF, at some other organizations, we decided we will be just bolting on more and more things onto that. And we were saying, oh, we need more and more things to execute on the network. And at the same time, we were running into a problem with the CPU and the memory, and we were trying to build bigger systems, but there was more software and more shared infrastructure that had to run on top of that. And then some people said, hey, you know what? I2RS, it can help us solve some of the problems that we are seeing, with the growing network operating system and not having enough resources on the box. We can also take in there like PC and PSAP. I just chose I2RS because it is pretty interesting to me. And the things here that box me the most is our controller agent architecture that we are somehow continuing to pushing on. And I'm saying, guys, it's too complicated. In my opinion, we should really abandon the controller agent architecture because it is ending up being a mess, and then you have controllers on the controllers, you have hierarchical controllers. You are, getting in a way lost in different controllers, what each one is doing, and you are hiding too much network information behind multiple agents and controllers. One of the things which I really liked about the I2RS, it was the initial services, focus on the services they included. And they said, hey, you know what, we would like to manipulate these services, this application, as well, as the RIB. And this focus on this, applications is something that I find attractive and that we are touching upon in different areas of the IETF, but at least to me, it looks, a little bit of unstructured. And I would like to see more proper layers, because if you look at any network element, we can say we have the forwarding and hardware abstractions, we have the shared infrastructure and the data, and then we have the applications on top of that. Now, if we look what is where and saying, hey, look, what is the forwarding and the hardware abstractions? We have people who know packet pipelines. We have people here in the IETF community who are building and working with them to provide us, hey, you know what, here are the models, here's what we can support, what we can provide as a high-level model, and decide I'm not saying what should be the transport for that, I'm just saying here's the model, what that hardware can do. It can be vendor-specific, but as long as we can agree on the common semantics and the common syntax, we can make a big, step forward in having some, common model that everybody will understand. I love to go back to the ACL example. You have ACL and you have filters. Why can't we have one common name, whichever one it is, to enable filtering on a box? If we can achieve on some functionalities to have common names, it's easier to build forward. So with that, if we can decide for each one of those layers to have a common naming convention with the common models with the minimum functionality, we can move forward and say, look, if we decide that we can layer that in such examples where we would be for each application, for each shared infrastructure framework, that we would be saying, here are the models, here are the frameworks that we would like to work on and support. We can make, again, I would say we can make a lot of progress. And there are things like that already out there. Because if you look at the gRPC, oh, you want a grib? Does it work for everyone? No, it works for someone. But it's already out there. You can manipulate it, giving it the APIs. You can get the protobufs. You can change it, model it. But do we want to adopt that? Or do we want to see and make sure that it can work for a much wider community and for much wider use cases than for just a certain type of use cases that that has been proposed and done. And I would say, with all of this is RIP to I2RS. It should rest in peace. It was a useful exercise, but the outcome of that wasn't very useful. The architecture wasn't there. I liked, okay, here are the services that we should focus on. This is what we would like to be able to manipulate. Let's find what would be the right way to get them, at each correct layer, the actions that we would provide to the users in different ways. Because I don't want to address a protocol through a controller. I don't want to add another layer of abstractions between it. I would like to be able to talk directly to the protocol daemon, get the actual state from the protocol daemon, compare it to the state on the, on the wire, and know what is the situation between, my intended and my actual state. If I'm going through anything in between that, I don't know how much information is hidden from me, what, what I can really, what I can change, what I cannot change, and simplifying such actions would move us forward in, again, achieving better programmability of the overall network. Now, do we want to do some work like that? I'm not sure, because we have some of our own, employer restrictions. We have, some of our own ideas. But as I said, it's a thought experiment that each one of us can do, and I just wanted to give you some food for thought and say, maybe we can, propose something else and see if it can be useful or not. Thank you.
Jeff Haas, former I2RS chair. So rest in peace would be wonderful, except for this is not resting in peace. This is the undead coming back to haunt you.
I don't want to, resurface a zombie.
Oh, that's fine. So the presentation has a lot of excellent points. I2RS in all objective criteria for what it was supposed to have been accomplished failed. We ended up with models. We ended up with the vestiges of a mechanism that supposedly used netconf to actually do that work, and people are not deploying it. So from that standpoint, it is a failure. But over the time that the working group existed and that the models got worked on, we helped the netmod and netconf groups change the protocol, change their mechanisms. The current data store model is largely influenced by the I2RS work. A lot of the dynamicity that we had in terms of things in netconf was pushed partially by I2RS back in the day. A lot of the components that we actually talked to, the RIB model that we have in IETF got a big upgrade because the I2RS people were looking at the contents of things with great scrutiny. So there's a lot of inputs that this failed experiment had in terms of pushing on the rest of the IETF ecosystem to develop good stuff. And to a large extent about your components, we're looking at, to some extent, the result of the failure that was projected, which is if we don't actually solve the problem in IETF, what we're going to see is that vendors are going to fork off and do their own things. And the most successful of those obviously is the work from Google for Rtgwg company. And part of the problem is the work is not done here. We don't get a lot of say in the matter. It's the Walking Dead of SNMP returned in many respects, so we get all the sins from that. But people are solving exactly the problem spaces we knew were needed to be solved in I2RS. People are doing RIB programming. Some people are doing FIB programming with different models. We're getting telemetry via various streaming things in lots of different places. The one success that we got out of a lot of that is, regardless of the transport, whether it's thrift, whether it's protobufs, whether it's something else, a lot of people have actually gone down the road that we sort of pushed them to, which is Gang is the high-level modeling language that stuff gets done in, so that at the very least the models can interchange.
So with most of your comments, I agree. I put back this slide on because this is what I see, what was the value coming out of the I2RS. I still see there's a lot of controller agent coming forward, and I would like to say, let's try to remove that, put in proper software layering in between it, and decide whichever framework we want to support on, or whichever one will be de jure at that moment. that can be easily, plugged on top of that.
So I tend to agree. I think those things are necessary, and I will leave the final comment with prediction. As long as we force this work to touch NetConf, it shall fail. The groups in that, the people participating in that group do not have an agenda that aligns with us.
Rob Wilson, Cisco. Actually, going back on Jeff's point, I think in terms of where we got in NetMod within the NMDA architecture was we almost got to the point of defining what you'd need for I2RS, and then we didn't do the small bit at the very end. So the architecture talks about how you would do a dynamic data store, but doesn't do the final step of actually defining one, and ideally saying how does the data merge in with the existing one. So I still think actually there's a small step from that point of view to enabling this functionality, because the data models have already been written. Whether that's the right thing to do is an entirely different question.
I will resist my comment on the NMDA architecture. I almost took the bait.
Dean, what's your personal position on this?
Excuse me?
You've kind of presented the facts. What's your position? What do you think?
Well, we have developed a bunch of models that people will not implement it because they are too complex and too big. There are parts of the models that are being implemented and are being used, but it's a very minor, part of some of the models that are being used. And it is the idea to, instead of trying to model everything under the sun, trying to see what are the, to come to a common semantics and syntax for the key functions and services, and say, here's the model. What framework will we use for the, to generate the APIs? Will it be netconf Yang, or will it be gRPC or Thrift or anything coming down the future? We should make sure that what we built is flexible and open to those new frameworks, that it's easily that you can easily move it. One of the things is that I'm saying, why can't they have a fib model and the rib model, understand how the rib to fib translation has been done on those models, and just compare them and know what is my actual state? So I have to know too many rib models and then too many fib models from all the different vendors, and then I can, and have the access to all of that in order to be able to start doing things like that, which gives me a much better overview and much faster overview what is actually really on the wire versus, what some of the other groups are doing. I'm also a little bit worried that we are still pushing forward, and that a 20-year-old technology, which was first proposed in November 2002, so we are now coming to the 70th anniversary of a 10th year of a 10th year of technology, is becoming the main network management technology. And it is not the friendliest programming tool. We have moved forward, and I would like to see us being more flexible to those new tools and new frameworks. I've been saying a long time, decouple netconf from Yang. Don't keep them connected.
Are there any actionable points of your presentation you would like working group to take? Is there anything you are calling for, or you just for your information?
So I'm just trying to finish something with regards to work. For the previous presentation and for this presentation, I'm planning to write up a draft, set of requirements and action items, and release it before the next IETF meeting.
That would be great, and thank you for presentation. I think we are just in time. Thank you, everyone, and we will see you on Friday.
And anyone who hasn't signed the blue sheets, please either come up here or go to Yingjin, holding them up on the left from your point of view.